Okay, so as promised, another video for my students in Java classes. There were some questions about Maven, how Maven works and what it is. So today we're going to discover or cover what Maven is, how to think about it. We're going to install it separately from Intellij. We're going to launch a new project separately from Intellij. This will be the explanation essentially of how to use it. Without Intellij, so there would be no confusion and mixing up between Intellij and Maven. Then we are going to go to Intellij and use it without Maven to create a Java project. And we're going to install an additional library in our project without Maven, which will show us how difficult that is. And of course, we're going to then finally create a Maven project with Intellij and add some additional libraries and perform some additional tasks as well, maybe. So to do that, I have a virtual machine, completely new, fresh virtual machine that doesn't have anything installed on it, essentially, almost. I'm going to restore that to a specific state, so it wouldn't actually have anything on it entirely, almost. And let me launch that up. Yeah, so this is going to be a Windows 11 machine, pretty much fresh machine. The only thing that it has is a Chrome browser and Visual Studio Code, and also Maven downloaded but not installed. Also Intellij downloaded but not installed. So if I open up my downloads page, I do see Intellij downloaded and Maven downloaded. All right, so that's what I wanted to check before delving deeper. So the first thing is going to be to install Maven completely from scratch and install Java without any mentioning of Intellij. So first of all, let's do that. And this is supposed to illustrate what Maven is. So as a definition, let's provide a definition first. A Maven is a dependency management and build tool for Java projects. So Maven is a build tool, and we'll discover what that means as well soon enough, and a dependency management tool. MGMT tool. MGMT means, of course, management. A build tool essentially helps us deploy, compile, package, and maybe even ship our applications, Java applications. Meaning that if I create a Java application, I want to package it up into some kind of a executable file, let's say a jar file, the Java archive. I'm using Maven to do that essentially. And a lot of people obviously are doing that with Maven as well. And for dependency management, dependency in this case means not another class as in the term dependency injection, as in the design pattern dependency injection. The dependency here is a completely different concept, in a completely different context, and it means a library for the project. So a project depends on another library, and this library is called a dependency. I will explain and delve deeper into this schematic as we move along with this plan right now here. So let's try to install Maven. So if I go to Chrome and I'm going to go to Maven, essentially just enter Maven and it will be the first result in Google. I can download it by pressing here, and I need to find a zip file, which will be Apache Maven zip file. I already have this downloaded, so I will not do that again, because in my virtual machine my disk is a bit slower, so its downloads are also a bit slower, so I already have it downloaded and also unzipped. So this is the unzipped Apache Maven folder. So what does it contain? It contains the Maven tool. The Maven tool is essentially a command line tool, a dependency management and build tool for Java projects. As we said before, it's very important to repeat the definition again and again until ingrains in our head. And the main folder that we need is, of course, the bin folder, which contains the essentially binary files. Not some of them may be binary, but some of them are not. And the commands, so essentially CMD files or scripts to launch the Maven executable. So Maven is just a command line tool. Yeah. First, another thing to remember. So if I press CMD and open up CMD in this folder, I can launch Maven and check it out. So MVN, and it launched, but it produced an error that Java home environment variable is not set up correctly. So for Maven to be useful for us as a command line tool even, we need to install Java. So let me do that as well on this fresh new machine. I'm going to go to Java install, and let's see what kind of a Java runtime, JDK, Java development kit is going to be suggested as a first one. There are multiple JREs, JDKs that are possible to use, multiple Java distributors, Azul, Oracle, OpenJDK, even more. So we have to choose which one we want. OpenJDK is, of course, probably one of the most popular ones. So we can take a look at that. Right, so let's try it out. Let's see where we can. Why I'm not seeing the ability to download. Download and install. Okay, I guess this is just the instructions. I usually don't install it like that, so let me see. Java download for Windows. All right, here it is. All right, so let's see that. Okay, this is the old version, so let's try and do OpenJDK. Download and install is somewhere buried. So I'll just click this and let me check it out here as well. Right, so for Windows, where is the download? JDK.net, JDK 20. I don't need early access versions, I just want the normal version, so I need a zip file. This will be the Java development kit, which contains the GRE, Java runtime environment, which essentially is just the Java virtual machine. You can think about it that way, with additional, of course, dependencies. So after downloading the Java development kit, we can take a look at it here, and it is here. So now we can essentially extract it. I'll extract it in this folder, the same folder I'm at currently. If you installed, if you use Intellij, you probably didn't do this step, because Intellij contains or allows you to download Java version internally, and it essentially can provide some management utilities, like you can install a new JDK, a new version. You can use multiple Java versions with Intellij. So essentially, it's like a management tool for your different Java environments, different Java versions. So Intellij can provide an abstraction and management utilities for that, but we are doing it raw now, completely without any help from Intellij. So that's why this step might be unfamiliar. Right, so I do have the OpenJDK installed here. So now let's try to run Java from here internally. We need to go into the bin folder again, which is for binaries, where are all the compiled, utilities and everything like that. And it should contain Java compiler and Java runtime, so JVM. So this is the Java compiler, and this is the JVM essentially here. So I'm launching the CMD again in this folder, and just going to run Java. It should throw out a lot of like usage instructions, which is completely correct. And if I am not mistaken, I should be able to run Java ---- version to see that we are indeed using OpenJDK 20, which is what I wanted. So I currently I can only use Java from this folder because my Java is pretty much installed on a like in the downloads folder, or not installed, even downloaded and unzipped. If I wanted to just launch, my command line and then use Java from any folder I like, I need to configure the path environment variable to be able to find, for my operating system to be able to find the command Java. So that's what we are going to do as well. So we now need two environment variables changed. Essentially, to launch Maven, as we saw before, we need Java home, and we also need to modify the path environment variable to launch Java without any need for fully referencing this full path, right? So let's go here, and I'm typing environment environ, and I'm pressing enter. You probably will not see. You're going to see like a incomplete view of this start option here, because for some reason on a virtual machine Windows 11 does not work. Probably some kind of a issue with interconnection with or some kind of interoperability with the GPU. I'm not sure, but it might be. I didn't troubleshoot that yet. So environment variables. Environment variables essentially are just like global variables in your machine. Can be user level, can be system level, so for all users or for your own user only. These environment variables are accessed by, for example, by Maven to know where, for example, Java is installed, because Maven is installed completely separately. We download it completely separately from Java. So how am I going to do that? So first of all, we know that we need a new environment variable. So I'm going to create a system environment variable. Be very careful not to delete any, just press new, or you can press edit, well, not edit, but press, just press new. I guess that would be the best approach here. So I'm going to use a system environment variable, and it will be called Java home. Sorry for that, Java home. And what do I need to, this is of course the variable name, and what value do I need? I need the value for the JDK itself. So it's not the bin folder, it's the folder where everything currently lies. So the JDK folder here, I think this one actually even. How do I know this stuff? Well, it's just Maven documentation can be browsed through, or you can just believe it, and and it's basically from the documentation or just general knowledge and experience. Yeah. So now Java home is defined, and I can press OK and OK again here, which should resolve the error after we restart the CMD. We should resolve the error with Maven. So now I'm going to go to the Maven folder again and I'm going to try to launch it again. I'm going to go here, bin folder, then I'm going to launch the CMD in this folder, and I'm going to launch Maven again and see if now we have no error for Java home, which apparently I think we don't. Yeah, now we have Maven is launching correctly. So now it can find the Java runtime environment, Java compiler, so the full JDK with all of its dependent libraries and the dependent utilities and all that stuff. So first thing is to define the Java home environment variable. Now, just because of that, I cannot still launch Java independently anywhere I want. For that, I want to change the path environment variable, and to point it to just deleting this old one, to point it to my downloaded Java version for OpenJDK. But of course, I need to go into the bin folder, where my Java utility is, command is, and I'm going to copy this full path where my Java command is. So you can see here, there is a Java command, and I'm just copying this folder here. And again, I'm going to type environment, and then press enter, environment variables, and I'm going to add, not add, but I'm going to edit the path variable this time. Be careful again with the path variable, don't delete anything here, just click on the path variable with the name path, edit, and then press new. And then at the end, just copy paste this path. The path does not need any quotations. It should be pasted like here, like so. You probably could just add another slash at the end, but it's not needed if I am not mistaken. So we are going to specify this, and then let's try launch the CMD again, and let's see if we can launch Java independently from any location. Yeah, we can. So let's recap a bit what we have. Now we can launch Java independently from any location we want. We also downloaded and unzipped Maven. So now Maven, we can launch Maven independently, but not from any location we want. We still need to go into the downloads folder in that Maven bin folder. If we wanted to launch Maven independently from any location, we would need to also specify where Maven command exists in the path variable. So as a recap, we can also say that the path variable is a very important variable in our system. It tells the operating system where to find different utilities that we call on. So if you at any point want to call, for example, there's a very famous utility called ping, which essentially can be used to check whether you are connected to the internet, or whether the server you are going to ping is alive or reachable from your location on the network. So this ping utility exists inside of Windows, and the only reason we can being in any path we can access it, like I can be in the users directory, or I can be on the desktop, I still can access the ping utility, is because it's in the path. It's reachable through the path. The path is essentially a variable containing different directories, where when you call some kind of a utility like Java or ping or whatever, or TCP dump or traceroute or something like that, it's essentially looking at each of those paths and looking for that command. That's why path is very important. Right. So now let's do one more final modification and add Maven as well to the path variable. So environment variables and path, edit. And our Maven directory was, I believe, this one. Yeah, the bin directory here. So now let's add new, let's add this, and let's check it out. Just double check it, always double check your work. Downloads folder may be not the best location to keep those. We probably maybe we should push them into the program files to add those, like all the Java, JDK, and Apache Maven. It would be better to probably push it into program files, but might as well keep it in the downloads. If you know what you're doing, if you know that you shouldn't delete them, then you can safely keep them in the downloads as possible as well, but not really that neat and tidy. So you can consider placing those folders somewhere else. Now I should be able to relaunch. If you change environment variables, you always need to relaunch your command prompt. And now I should be able to just launch Maven from wherever I want. And we can see that indeed now Maven is launchable from wherever we want. That's it. So the first thing we did was, let's take a look. We installed Java and Maven without IntelliJ. We set the Java home directory. We added Maven and Java to the path, and now we're going to create a Maven project without any Intellij help from Intellij. So let me just mark down what we did here. So this one is done, this one is done. And now let's not mark this yet. Let's first of all discuss why we are doing this. Creating a new project, Maven project, without Intellij will completely disconnect or untie Maven as a concept from Intellij as a concept. Intellij and Maven are completely separate things, although they integrate very nicely together. So when you are learning using Intellij and generating Maven project using Intellij, it immediately bounds you to believe that Maven and Intellij are somehow completely connected, but they are not. These are separate tools with a good integration, but the integration is not mandatory, of course. So how do I create a new Java project with Maven without the help of Intellij? I am opening the command line. Again, Maven is a command line tool, so I need a command line or some other way to launch Maven, like Intellij, which is also just a launcher for Maven essentially in that regard. And I'm going to navigate to my desktop, and I do have a projects directory here, so I can simply navigate to the projects directory, and then I don't have any projects yet, so let me generate a new project. To generate a new project, we do need quite a big command, which I think I will just simply copy part by part and explain what it means. So the first thing you need to do is to call Maven and then call the generate archetype. Well, generate archetype means essentially the command generate. You can think about it this way. Don't worry about archetypes just yet. Archetypes are like project templates. If you don't want to worry about them at the beginning, actually you shouldn't even worry about them at the beginning. Think about it as we are starting a new simple project. So we are going to generate a new project, and then we are going to specify the group ID, the project ID, and then the artifact ID, which is essentially just going to be essentially a template for our project. So what is important here? What is important here is that you should name your group ID is essentially the package name that the Java project will have. Essentially, it also has meaning, or the semantics are also defined for the Maven context. So essentially, it has some meaning in the Maven environment. Like if you wanted to distribute a library using Maven as a Maven library, then the group ID would identify your library for the whole world essentially. So I do have a domain cf.mindaugas. Mindaugas.cf, so I can use cf.mindaugas reverse domain notation, but you can use com.example if you want. We are not going to publish any libraries ourselves, so it's perfectly fine if you can just leave it if you want, just a default, some kind of a com.example or something like that. But this is if you own a domain, if you have bought a domain, this would be the reverse domain notation usually written here. Which would uniquely identify, because domain names are unique, this would uniquely identify your project, your company essentially, and everybody would know that you are creating this library, this Maven package. So for example, let's say Google wants to create a Java library or package, Maven package, they would create com.google group ID, or a library with the group ID of com.google. And then the artifact ID would be the name of the library. So I'm going to just call it DemoProject, or maybe MVN DemoProjectDelete. Delete at the end means just I want to delete it. It will not contain any things that I experiment with. It's a deletable project essentially. And the archetype ID is the maven-archetype-quickstart, which will just create a simple Maven directory structure, which we will investigate as well. And the only thing that else I want to add is the interactivity parameter to make it not interactive, because if I'm not going to make it, it will ask a few more questions, and I'm just want to one liner for project generation. Right. So that's pretty much it. We should be able to generate the project, and let's see what it does. So essentially, it downloads a bunch of necessary packages for Maven itself to work, and the project should be in progress of being generated. So let's see if we are going to see it. Right. We have a warning, but we don't particularly care in this case. These are validation issues for the plugins, build success, and we can see that indeed the project is ready, or as close to ready as we can expect. So what do we have here? Well, we have the same project structure, essentially the same project structure as inside Intellij. I can actually show it to you by just opening CMD in this folder and using the tree command with, I think, is the P option or F option, sorry. As you can see, so the folder is MVN demo project, and then it contains the pom.xml file. The pom.xml is a configuration file for your project, Maven configuration file for your project, and then src directory, which is the source code, and main and test. It's exactly like we had inside Intellij if we generated the project using Maven. So this is the standard Maven directory structure. Main, Java, com.mindaugas, app.java will have our code, like our main Java entrance point for our application, and the test folder contains all the test code. So for example, app.test, app.java, right? So the only thing I want to show, the only last thing I want to show, this is already, we generated the project. What can we do with Maven and so on and so forth? So first thing it does is it can generate a new project with a default structure that is very, very recognizable by other developers. Additionally, I wanted to also show you how we can package the application using Maven. Remember, Maven is a build tool and a dependency management tool. So let's demonstrate the build capabilities of Maven a bit. First of all, I will navigate to src main. Sorry, I got used to Linux command line, so the slashes are in the reverse there, like in the they are Windows uses backward slashes, Linux uses forward slashes, so that's why I'm a bit confused here. I'm going to navigate to this folder, and I'm going to, let's say, launch, well, I could launch Notepad or something like that. I think Notepad will not work very well. Yeah, it does not work very well in my virtual machine. So let me quickly just install, or maybe not, yeah, let me install Notepad++, and I will be able to use that. Or maybe it will be faster for me to just navigate to this src main Java file and then create a new file. Oh, I do have it already, so I can just open it with using some kind of a simpler tool like Visual Studio Code, Notepad++, Sublime Text Editor, or Notepad if you want. You can develop Java with Notepad if you so wish. Of course, it will be much harder, but you could do it. So we can see indeed that the package, well, let me write it completely from scratch, just to show you what it does. So of course we need to declare the package, and we are going to go public class app, if I'm not mistaken, yeah, the app, and we are going to go with the public static void main and string array args, and we're going to system out print line, some kind of a message, and that's our Java application essentially for demonstration purposes. So you can see that in Intellij is not needed. I could have written this in Notepad and would have been completely fine. If I didn't make any mistakes, I'm not looking at looking for mistakes right now. So let me just simply close that out, and let's try to package it up and then launch it. So one way to launch it would be to just completely launch it with Java from the CMD. So for example, one way to launch it would be to just run this simple app.java file. Yeah, it works, but this is, of course, does not involve Maven whatsoever. So we are just invoking Java directly. What can we do with Maven? So with Maven, if I return to project root directory where the pom.xml is, if you are using Maven, the root directory is where your pom.xml file is. So you can also see it here, pom.xml. Now, if I were to inspect pom.xml, we would see that, well, let me try and inspect it. We would see that indeed it does contain a packaging directive, which is the jar directive. And also it does contain a dependencies directive here, which we'll talk about a bit later. So now let's see how we can build our application. So let's say if I'm going to enter Maven package, it should invoke the default packaging utilities of Maven in this project, which should create a jar file because the pom.xml file contains it essentially contains the jar specification on it. It specifies that the jar file needs to be created. But Maven, when it packages those the whole project, it does a lot more things. So let's try to spot what those things will be. So let's see. I'm launching Maven package. We can see that indeed it shows the jar option, and we'll see what it does soon enough. So it's essentially downloading a bunch of other files and all that stuff, and let's see what it did. So Maven project delete, the name, building the snapshot version, this is the version. It downloaded a bunch of necessary dependencies for it to work, and then it launched the compilation phase and recompiled the module. Unfortunately, there was a error in the compilation. Why? Well, this is because our pom.xml apparently specifies that it doesn't specify that the Java version, but the Java version here by default is probably Java 7, at least it writes like that. So we need to specify which version we want. So let's quickly open Google and say Maven specify Java version. Very simple. This is a setting, and now you can see how you can control your whole Java project using Maven pom file. It's essentially you can specify which version the JDK needs to be running when you when you are when you want to use a specific Java version, let's say. Well, you do have a specific Java version installed on your computer, or I do have a specific Java version installed on my computer. But there's essentially a compatibility parameters and which how Java compiler can support multiple versions. It can produce bytecode for multiple versions from the same source code. It can produce multiple versions even if you have like a Java 20. You can still produce bytecode for Java, let's say 12 or something like that. So let's specify Java version, let's say maybe 9, maybe 20. I don't know. I don't remember all the options, but let's see if that would work out for us. Let's see Java version 20. If not, we will change it out to something other. So maybe, yeah, maybe let me try to use the options that I know better about. So Java, not Java version, but sorry for that. I will go to the old version here because I don't want to. Yeah, I do use I do know, and I specified this option quite often when I explicitly used Maven. So let me do 1.8 just for speed. We could try to launch the version 20 or something like that, maybe even with the same options, but it doesn't really matter which version for us today we are going to be using, as long as it works. So let's try this one and let's see whether it will work. I'm just trying to launch it and for it to work as fast as possible without any issues. Yeah, that seems to be working fine. Build success, and you can see indeed that there are several steps that it did. So, for example, scan for projects, that found a project from POM.xml. Then it started filtering files or doing something like that, recompiling. So the compilation step is here. Then it downloaded some necessary subtools or sub-projects for that. Then it actually launched the tests. In Maven, by default, you cannot package a non-working project, and a non-working project is essentially a project that cannot compile or the tests fail. So it does run all the tests. The test run is 1. So you imagine you are packaging the application, and immediately the compilation phase is done, the packaging phase essentially is done, and the testing phase is also like inherent in the packaging process itself. So it's like a very convenient process build tool. That's what we wanted to prove. Maven is a build tool that automates packaging your application into a jar. So where is that jar now placed? Very simple. Default Maven project structure specifies that src directory is where all of your source code, so essentially the functional code, the features of the functional code in the main directory, and the test code in the test directory. And then the target directory is where all of your compiled assets go in, including the ones that are packaged into like jar files or var files, WAR, which is web archive, jar is a Java archive. And we can see indeed that our project is actually packaged up. So this file is actually nothing more, nothing less than just a zipped file, essentially. An archive. So you can even try to uncompress it or unzip it. I don't have the utilities like to inspect it so well. I would say at least I think I don't use Windows 11 yet. So this is my virtual machine to try it out. Now, I will not inspect what it contains, but you can definitely, if you have like a 7Z tool or the WinRAR tool, you can WinZip, you can open this package up and see that you will have like a similar structure to like classes and things like that. So it's just an archive of Java classes essentially. What I'm going to do is to try and launch it. So this jar file is essentially an independent, packaged up, fully functional our project that we created. So I can just take it, press Ctrl X, go into, let's say, for example, my desktop, where nothing exists, no Java, no nothing exists there, and I can just place it here, launch the terminal, and try to launch the project. Yeah, let's try it out. So if I want to, I will just use bash. I will use the CMD and go to desktop. Sorry for that, and then try to launch to Java. Well, launching it again is a bit. You need to know what you're doing a bit, but it's very easy. So essentially, you specify the class path. There are other ways to do it. You can launch it without class path if the jar file contains a manifest file, but don't worry about it. Just specify Java class path and specify the jar file, and then your full class path. So I think it was com.mindaugas.app, and indeed it was. So Java class path our jar, and then our full entrance point to the application, which is the main Java class, where the main method is. And if I wanted to take this jar, place it on a Linux server or other Windows server or multiple Windows servers or whatever, you can give it to your neighbor, to your friend, and he will, if as long as he has Java installed, he should be able to 8 and above, he should be able to launch it and run it. There are some restrictions regarding the bytecode generation level, but essentially this is our fully functioning complete application with all the necessary assets compiled into one and packaged into one thing and can be distributed as is in majority of the cases. There are, again, as I said, some additional things to know, like Java modules invalidates my statement that it's completely independent because our project can depend on other modules. So you might need to distribute not only one jar file but multiple jar files. But that's a minor detail, I think, for a later date. So this is what Maven does. It allows you to create a standardized project with a standard directory structure. It allows you to easily install dependencies, which we didn't cover yet. We'll cover that soon enough. And it allows you to package your projects very efficiently into jar files, and it runs automatically all the necessary compilation steps, test steps, and all of that. And of course, there are other tools to package Java applications into jar files or WAR files or whatever you like. But Maven is a very standardized and liked and popular tool in the ecosystem of Java. Okay, so I guess we proved that we showed how to create a Maven project without Intellij, completely from scratch, configure it, launch it completely independently from Intellij as well, and even take the jar file out of our folders and launch it completely independently from the folder where our source code lives, which means that we could take this file, push it into another completely different server, and use whatever application we created here, like a calculator or whatever, and use it independently in other environments. Now, let's transition to this step, and I will show you how Maven is useful for dependency management. So let's go here, and I think I don't have Intellij installed yet, so I do have it downloaded. So let me try and install it quickly, or as quickly as I can. I already have double-clicked on it, but the virtual machine is a bit slower than my real machine, so it will delay a bit. Yeah, quite a bit, because of course the disk needs to be read, and it's a bit slower than without the hypervisor. All right, so let's see what it does. And let me just quickly shut down all of these things. We already finished with these demos, so we don't need that at all. Right now it's loading up. Right, let's see. Okay, next. Okay, good. I don't need a desktop shortcut. I can add bin to the path. Like if I wanted to launch Intellij from any location using terminal, again, this is the same thing. It would add automatically Intellij to the path variable, what we did for Java and Maven. So that's what this means as well. Add open project, I always choose this. I don't create associations, and let's install. Should complete pretty fast. And we'll be able to see how Maven helps us out with dependency management. So let's, while it is installing, let's talk about what dependencies mean and a few other terms. A dependency is a library in this context. Library. So your projects will most likely, even like intermediate projects, contain a lot of libraries in Java and other ecosystems like Python, JavaScript, especially JavaScript. So a library is essentially the code that other people have written and decided to share it with others to make their work easier, more standardized, and all that. Libraries make us efficient and the developers efficient, but can suffer from security issues, can suffer from performance issues. You shouldn't implement everything. You shouldn't just use libraries for everything. You should implement some things on your own sometimes. This is again especially true in JavaScript, where in JavaScript you even have packages for even a method like add. So you are downloading the package for a method like add, which is of course comical and nonsensical, but I wanted to add it as a precaution. So a library extends something that maybe Java standard library does not have. For example, like junit is a library for testing Java code. SLF4j is a library for managing your logging capabilities, logging utilities. We do have like libraries like Guava, which is Google Java libraries that extend Java capabilities, provide the collections, string methods, other utility methods to make our Java code better in a sense and more functional. It adds some functionality to our Java code that we can use. For example, a multi-set and multi-map and all that stuff. So dependency in this context is a library. Don't think about it as a dependency in terms of like dependency injection design pattern, as I said before. And then there is another term which is called transitive dependencies. Transitive dependencies. A transitive dependency is just a library upon which or on which another library depends. So let's say you have JUnit, and maybe JUnit itself depends on another library. As a project, JUnit is written by other developers that also included other libraries inside of it. So, for example, Hamcrest is a very well-known library. So I think it's even JUnit 5 depends on that. I think so. We'll see. Maybe assert4j, but I'm not sure. But essentially, a transitive dependency is a library on which another library depends on, and then on your project depends on that library as well. So my project depends on JUnit for testing, and JUnit depends on Hamcrest for advanced assertions or something like that, right? So this is a transitive dependency, and Maven is especially useful for that, because if you don't have that, if you don't use Maven for that, you will need to install everything on your own. So now Intellij should be installed, I think, already. So let's run it. And let's create a new project without Maven first. Right, let's confirm. Don't send statistics. Let's close this one. Quickly customize it to my liking. And that's it, new project. And let's call it no Maven delete. I will add it to my user desktop projects folder. Here, no Maven delete. Yeah, the path is correct. And I'm going to just create a simple Java Intellij project. It did detect a Oracle OpenJDK already. I don't know why and how it did that, but you could of course download other libraries. Oh, okay, I did have it already installed, but you could of course choose like Amazon Corretto, or you could choose even different versions like that. You probably already know that, so I will not show it today. I will not add a sample code. I'm going to just use everything almost default here, and this is okay. This is good for me, right? And this is our new project, essentially almost created. Always download and automatically configure Microsoft antivirus defender system to allow this project to execute and download stuff more efficiently. Right, so this is it, indexing dependencies. And while it's indexing, I want to create the project. So what do I do when I want to create a project? I want to create a package probably first to group our Java classes more correctly. So com.mindaugas. You can, it's possible to create a Java project without a main package, but people don't usually do that, so I will show it like that. And I will create a main app class, which will contain the main method, of course, and will of course print out something very simple like that and test it out first. So let's try it out like that. And I will try to include, for example, another library called guava. Like, so everything is working. So now let's talk about Maven dependency management capabilities by showing you in contrast what you need to do without Maven. So without Maven, this is a project that has no Maven, absolutely no Maven. First of all, I would not be able to easily, create a jar file with it. I would need to use other utilities than Maven, which is a bit more complicated, I think. The other thing is that I want to, for example, use Guava example for, let's say, multi-set or multi-map. So Java Guava multi-set. Multi-set is pretty easy. It has a pretty simple API. So let's see. Let's just copy this code and make it run. Right. So in our main folder. Right, so multi-set does not exist in Java. Of course, you cannot just import it and you just use it. We need a library. So how do we install it? One way is to use Maven, but we don't use Maven now. We'll soon use it later on. And you will see what is important with Maven. You will see the dependencies in documentation, like the in Bildung blog and in Oracle even documentation. I think even they use Maven already, but in personal blogs of other prominent Java ecosystem influencers, you will see Maven dependencies and Gradle dependencies always used. So it's very, very important to understand what is being done. So because I don't have Maven, I need to go into Google and check how to install Guava. So how to install Guava library in Java, right? So let's go to Guava or Java, and let's just open GitHub. I think I know that with GitHub, you just have the releases here. Yeah, we do have releases. It's a completely open library, open source. You can inspect the source code. You can go, let's say, what you can do. Android utilities tests Guava. XML says that's common. I don't know. HTML, IO, math for math related stuff, for example, big integer math. So this is like a source code for like different methods. You'll see different methods, different annotations, different capabilities that Guava provides. But for us, it's not important yet. It can be any library. For our purposes, it could be any library that provides jar files available for download. So how do I install it? From the GitHub folder, even GitHub repository. If I go to releases, I can see that immediately I can see that they provided Maven dependency. So it's of course easier would be to copy and paste but because I don't use Maven in this project, I need to do what? Well, I need to download the jar files. So which one do I need? I need the JRE one because this is for Android. Android uses a different essentially different package of Java runtime environment contains different packages, so it doesn't have some capabilities that the desktop environment or the standard edition has. Standard Java edition has. Also, Guava has a transitive dependency. It does depend on failure access.jar. So this is what I still also need to install. So let's download both of these, right? So we downloaded both of these. Now both of them are in my downloads folder. I think it's already downloaded, but still finishing up, probably being scanned by Microsoft Defender or something like that. And let's see if I can show it to you. So if I go to downloads, I will see Guava and failure access libraries. So essentially, if you wanted to do that, the same thing for JUnit, you could do that the same thing. Although to find JUnit jars is a bit more complicated. You need to go to Maven Central and download them by hand. So I'm not going to do that, but you could do it as well. And now I will need to go to, I think, project properties or something like that. Yeah, let's go to file and let's go to project structure and the modules. I think we will have the dependencies here. So this is not a Maven project, so that's why I need to manually add the jars and directories, jars and libraries from my downloads folder. So users, downloads, and Guava and failure access. Boom, add, right? And they will be added here. They will be visible here as a, well, compile dependencies. Let's keep them as compile dependencies. The indexing is happening right now. They also will be visible here, external libraries, in the project view. So in the project view, you can see your project here. Why did it do that? And your external libraries. If you open this drop down up, you will see all the default Java, essentially standard library classes for the Java 20. So all of these are in the default Java standard library, and then we added a few more. And now we can import whatever we need. So I need a multi-set, and I need a multi-set interface, right? And that's pretty much it. There's an assert here, which can come from JUnit, but I don't want to use it right now. I want to just, let's say, count how many let's have a few options. So I have like a bookstore, no, well, not Hagrid, let's say 50 Shades. How many books do I have for Harry Potter, and how many books do I have for 50 Shades of Grey? A multi-set is a Java collection, or not a Java collection, but a Guava collection. Let's say it's a collection that doesn't exist in Java itself. Multi-set allows duplicates, and Java set does not allow duplicates. So we'll talk about that later on, I hope. So a multi-set is usually used or often used for counting. For example, how many, I can just add a bunch of items like objects, like strings or numbers even, or mainly objects probably in the real world. And I can then ask that multi-set, how many objects do you have of particular kind, of particular instance. So let's say bookstore count Potter, and we will, if we launch it, we will see that it should be 3. Let's launch it and let's see if everything works. Yeah, it printed out 3. That means we were successful, and essentially we now installed external libraries without Maven. So now I will keep this open, and I will create a new project with Maven, and we'll compare. So new project. So maven-delete. The previous one was called no maven-delete. This one will be called this will be called maven-delete, and I will choose Java maven, same Java version. I will not add sample code, and I will just provide my own package name immediately. Maven-delete as an artifact is completely fine with me, and I can create it right now, and I will open it in the new window. Right, so these were the versions we needed to add. So Java compiler source 20. Okay, automatically add that. It's weird that it doesn't have the dependency for junit, but now let's see how easy it is to install dependencies. So I want to install dependencies for, let me just, of course, copy and paste the code for our previous example. Yeah, but let us allow it to synchronize everything, and then we'll be able to add the previous code. Let's add that previous code here. So src main app. So the same example essentially. Yeah, functionally is the same, but of course it will be different for the different experience will come from using Maven and installing libraries. Right. So yeah, for some reason it did not generate my package name, but doesn't matter, I can generate it fast myself. So com.mindaugas and my app class. Yep, and the same everything with the code. So of course I don't have the Guava library. I think it might even auto-suggest us something, but I wouldn't count on it too much. Add Maven dependency. Yeah, I think it would be able to. Yeah, it does. It does find it, so we could just add it like this. But the regular way or the common way is to go to Maven Central and check it out. So go to Maven, just Google Maven Central. This is an important knowledge of Maven, how to find like different packages. And don't go to Maven Central, maven.org. Go to mvnrepository.com. This is the one I wanted to know. And let's go to Guava, and I think it will, Guava, Google Core Libraries for Java. Boom, that's it. Go here, and then we will see like a bunch of possible versions that we want to use. Of course, we want the newest version probably without any vulnerabilities. So I'm going to use JRE 32, and this is the only thing that we need to copy here. And now we can paste it into our POM XML. So we create a dependencies directive and then paste this dependency here. You can open this side view here and then press refresh or load Maven changes here, and it should install your library very, very fast and very, very easily. Yeah, always download pre-shared indexes. Right, and then dependency appeared here, and you can see all the sub dependencies are also here as well. So what I can tell you right away is this. You just needed to copy and paste this snippet of code here, and did not need to go into a website, download jars. Then, of course, the jar files that we downloaded in the first instance, in the first example, need to be managed. They cannot be deleted. You need to place it in some safe location, maybe inside the same folder as your project or something like that. It's a whole mess, and you need to think about it. With Maven, you just specify the dependency you want. It will download into your specific directory in your user's profile, essentially, .m2 directory in your documents, essentially, and you will not need to worry about it. If you wanted to, you could even change the version. Let's say, I don't even know which versions exist. So let me check the versions. So what kind of version did we see for Maven? Was it 30? So say 31.1. I wanted to test out what kind of vulnerability there was. So 31.1 was it? Yeah, GRE. So GRE, and then I'm just refreshing this, and my project now completely has a different version. That's it. I don't need to go to to GitHub. I could do the same thing as I did in the previous project here, and I could go into the file, project structure, and add guava 31.1 if I wanted to try that out. And then a dependency for failure access, which will be probably different even. So we needed to delete those two, download the other ones, and all that stuff. Maven simplifies this process immensely, immensely simplifies this process. And that's why we say that it's a great dependency management tool. So that's what we wanted to prove. We did this, and we almost completed this. So let's complete this and finish it off. We have the 31st version completely installed and indexed. I'll just leave it as is. We could update it. You can see that because we have the imports, all the red colors are resolved, and we can just launch it right away. And it should print the same result, of course. Yeah, 3. And so essentially this completes the example. The only last thing I wanted to add is, of course, how to add a test of some sorts. So let me create a simple public static string method, just to add another library to a very, very popular library to our project. Return arrows, let's say, or something like that. And I will just return a string arrows like that. And I will test that method. So how do we test? Well, we create the same package structure as in our main folder. So Java, and it will be com.mindaugas and test app. So the name of the test class is going to start from the word test, and then the class name that we are going to test. So the app is the class that I'm going to test. And I'm going to create a test method. Because I don't have Intellij, junit installed, I cannot use the test annotation yet, but we will install it with Maven soon enough. So I'm going to go public void test return arrows. I usually do it like that. And you can specify a lot of other preconditions and success criteria in the name of the test method. The test methods are usually quite long, and they have even separate parts, completely differently from the source code, but that is for another day to discuss. There are multiple conventions, of course, to name your test. So test arrows, let's say success. Success. That's a misspell. Let me quickly check. It's a pretty late time. On my side of the world, so apologies for making silly mistakes. And we, of course, have the given when then pattern. So what we are going to do is, of course, given our main class, given our app class, return arrows, or we could provide some kind of a parameter to it, and then return a result. So var result, whatever it returns, and so given and when steps are essentially this one and the same line in this case, and the then step will be a different one. So then I want to assert. So I do not have the assertion library yet. So assert something. And let's install the assertion well, the testing library. So let's go in and take a look at Maven. Maven. Oh yeah, I have it open. So JUnit, and we can also, if we know the version, so JUnit Jupyter is the JUnit 5 essentially. So we can install the JUnit 5. I can use the 5.10, which is the M1 version, which is not the final version essentially, but I can use the final version of 9.3 if I want to, which 5.9, sorry, which is a bit more popular. So probably a bit even safer to use. So I can just take it in and paste it in as another dependency and reload. And all of these other dependencies that are needed for junit Jupyter to work are being downloaded. So AppGuardian, open test for J, and all that stuff will be downloaded immediately. And that's it. Now it's downloaded. I can uncomment my test annotation, and I'm just imported from JUnit itself, and that's it. And now I can even use, of course, the assertions provided by JUnit. Assertions, assert, assert all is not needed for me, so assert equals, and I have the expected value, and then I have the actual value. Yeah, expected. I expect this, and then I have the actual value, which is this. Of course, they will not match. I can run the tests easily. They will not match. The test should fail, by the way, now, and we'll see that. Yep, and we can see that I didn't specify like that I expect this string, not the one with 3 symbols. So you might think that this is a useless test, but it's actually not that useless. If even if it asserts like a very simple thing, if you have a bunch of tests like this, they actually impose a restriction on anyone that wanted to change this code. So, for example, if another developer wanted to change this code, the test would start to fail, and he would need to also change the test. That means that he might start thinking, second guessing himself. Maybe I didn't need to change that stuff so easily. Maybe I need to ask why it was coded this way, and start to be more careful and interact with people. So even in trivial methods, like I don't know, add, sort, or transform something, you might add a test just for future-proofing your application, so nobody would mess it. But of course, it's a completely different topic than the one that we wanted to discuss. There are a lot of test philosophies. Some people write a lot of unit tests and believe in a test pyramid, which means that unit tests should be plentiful, very fast. Then integration tests should be there should be fewer integration tests. It can be a little bit slower. Some people don't even write a lot of unit tests. They believe in only integration tests or mostly integration tests. There are a lot of philosophies there. All right, so what do we have here? We have a fully working project. And of course, you might ask, the last thing I want to probably show is, you might ask, hey, we used the terminal to launch Maven and to Maven package our application. Can we do that with Intellij? Yes. So the Maven tab contains a bunch of lifecycle methods. For example, Maven package is also here, and it would create, and it would launch the same Maven command. As you can see, if you wanted to see it here, it will be the same Maven, that's almost the same Maven command as we launched. Well, not the same, but it's very similar. So at the end, you will see that this is the Maven package command that's being launched. And you will see the same output that we had before, which would be tests are being run, the compilation step, the tests are being run, and then the packaging step, and the build is successful. And the same project structure means that we will see in the target directory, we will see the jar file, because again, package command checks the POM XML, and by default, it's actually using the jar format to package your application, and it essentially packages into a jar. So we could actually even specify that, but I don't think that's needed. So we package into the jar. So for example, what are other lifecycle methods? Maven clean simply deletes the target directory essentially. Yeah, that's it. Maven package creates a jar or whatever package you want, like var jar or whatever. Maven test runs the tests. So essentially all the tests will be run. Your application will be, of course, compiled and the test will be run. Right? So, for example, we could, mess up our test, and if you ran Maven tests, you will see the test should fail. Yeah, test failed. So is it better to run Maven tests rather than Intellij tests? No, it's better to run Intellij tests, because Intellij tests format the output a bit better than Maven in this case. Maven is not used for that. Maven is the Maven test command can be useful when you, for example, don't have Intellij, or just well, it's a convenience method. For example, Maven packaging does not work because the tests failed. You might want to just launch the test from Maven, from the command line. So that's why it's needed. But in general, we launch tests using Intellij because it displays them nicer. You can relaunch the tests, only the tests that failed or something like that. Yeah, but this is a convenience method. So compile will just compile their project, validate will just, I think, also compile and do something else. And you can have multiple configurations. You can even create your custom lifecycle methods. Maven is a very big tool. I hope this introduction would be helpful to at least start understanding it. Okay, so let's recap. We installed Maven and Java completely independently from Intellij and created a project and packaged it. Thus, we proved that Maven is a good build tool because we were able to create a jar file very easily and launch that application independently from the source code. And then we switched to demonstrating the dependency management capabilities. We discussed the dependency management terminology. What is a dependency? What is a transitive dependency? A library of a library. And then we created two projects side by side with Intellij, using Maven without Maven, and a custom and then not a custom but an additional library, and then with Intellij and Maven and additional libraries. And we demonstrated how easy it is to install libraries using Maven, how to change how it is easy to change their versions. And also I talked at the end about other Maven actions that it can provide. I hope you enjoyed it. Thank you for your attention and good luck.